the whole point of AI or machine learning is to map inputs and outputs. So therefore, we really have to rely on historical data to see what has happened in the past. So if you have inputs and outputs and there is no simple relationship between them to derive this input-output relationship, that is where machine learning can be the most helpful.
How do you, Ram, keep yourself up to date with the latest stuff that's going on in AI?
I think LinkedIn is a big boost for me. I have some really good, credible newsletters that I have always subscribed to. If end users or if engineers can map out the way a data flows inside their engineering process or engineering team, and we can start from those points. Not everything can be automated with a simple linear regression model. I don't think the mathematics of machine learning is the barrier, but the tools to enable access to machine learning is sometimes extremely new for engineers. I think there are many ways to cut this barrier of programming, and that is where Scenera can help, because Scenera is actually a visual programming language. It's just actually coding, but it's easy to really see how the code looks. It's still going to be FEM, it's still going to be CFD, surrogates, stuff like that, but the way we interact with these tools and at the speed with which we get the results is going to dramatically change. But I don't think there will come an AI that can replace CFD simulation or FEM simulations accuracy.
All right, ladies and gentlemen, today we'll talk about the future of artificial intelligence in engineering. And I have a very special guest, namely Ram, one of my friends and colleagues. Welcome to the show.
Yeah, thanks so much, Yusuf. Really happy to be doing this episode with you.
Really cool. Can you give the audience a little bit of a background? Like, who are you in the first place? What do you do at Synera? And what's your background?
Yeah, sure. I originally come from India. And I did my bachelor's in engineering, mechanical engineering. And also, during my bachelor's, I was part of a student racing team where I got much into simulation. And then I thought, okay, I need to build my career on top of this. So I came to Germany for my master's in computational mechanics at University of Stuttgart. And during my master's, I was part of Green Team, which is a Formula Student Club. And this is where I started using Synera a lot. As a student, really trying to optimize mechanical parts and things like that. And then I thought, okay, should be the future of engineering. So in Scenera, I'm a solution engineer and also the education program manager. So I primarily work with our automotive and aerospace customers, help them build technical workflows, help them achieve much better automation efficiencies with Scenera.
Really cool. We can talk about the education program maybe in a separate podcast. But again, as I said today, it's more about like AI and ML in engineering. I think one of the most critical questions people ask themselves when they start to adopt AI in the organization is probably, how do I even decide in the first place? Like, is this use case feasible for AI, or can I use AI for this particular problem? How can you assess this?
Yeah, sure. I think that's the most important question for a company. And what I realized through my experience working with global teams, engineering teams, small teams, regardless of the use case, is I think there exists a kind of a quadrant approach. So let's say there is a quadrant. On the x-axis is the size of your engineering team or number of engineering processes. And on the y-axis, the complexity of your machine learning use case that you can go for. So the bad corners there are two bad corners. So that is when small engineering teams, which have only limited engineering processes, start with complex workflows. They think, okay, now we need generative AI. I need to connect all my data in one place. When small teams think that we need to do everything as the first step, that is a bad zone. And there is another bad zone where large engineering teams, imagine maybe multiple departments, multiple processes, they try to do a very simple use case. It's good, but then the delta of impact that they will have on their whole engineering efficiency is limited. So these are the two bad corners. So there are two good corners. That is, small engineering teams which have limited engineering processes should always start with very simple machine learning tasks, sticking to the simplest models, working with whatever limited data is available. And the other sweet spot corner is for large companies, large engineering teams, which have multiple departments, and they need to think, okay, we have so much data lying around. we can start simple, but we need to head in a direction where the impact is on the overall organization. And this is a kind of success that I personally see with our customers, depending on, because we have customers from both startups to global OEMs, and the impact that they have with different machine learning is different. And the key to is the amount of engineering processes you have, and that correlates to the data that you would have, classic traditional data. And I see this as a nice starting point for teams to think about.
Yeah, I think the quadrant approach is really good, Ram. What I also thought about is maybe there's not a clear cut for some organizations in terms of like which quadrant am I fitting in. Maybe it's clear for them, but they still think, okay, there's so many algorithms out there. Do I have enough data? Do I have the right quality of data? Even though I might fit in one of the sweet spots, is it still for me? So how do I calculate the ROI, the feasibility, if it even makes sense for my organization?
Yeah, I understand. So that is also a very important point to think, especially as an engineering team. I mean, we are trying to automate things, and we need to be clear. Uh, the whole point of AI or machine learning is really, at the end of the day, we are trying to map inputs and outputs. Is there a relationship that I can figure out between a set of inputs and outputs? So if there is, traditionally you're working in an engineering team where, to get from an input to an output, there are so many steps involved. So let's say you're working for sustainability engineering, and you, in the early development, you start with CAD, but there is no way to know what kind of CO2 emission this part will produce throughout its whole development cycle.
Yeah.
And there is no one formula to do this. So therefore, we really have to rely on historical data to see what has happened in the past, and then maybe fit a model around this to see if I can already, during my development cycle, predict some kind of CO2 emissions, or think about sustainability. So this is a very big picture. So if you have inputs and outputs, and there is no simple relationship between them, and there is no clear mathematical formula to derive this input output relationship, that is where machine learning can be the most helpful with the current state. That is where, for sure, engineering teams can get the maximum impact. And so if you have, like, let's say you are working in a 20-step process, and and you try to do machine learning from step 1 to step 2, it won't have the biggest impact because the next step is much closer. So there is nothing to really not guess or something. We know the next steps guess, but in a development cycle, when the steps are too far away, but we still need that data when we develop our products, that is more important. So if you have some data, or any data, where you have an input, you have an output, but there is no clear logic or relationship or scientific principles to figure them out, then I think machine learning is extremely valuable there.
What should actually be the driver in an organization in terms of machine learning projects? Should it be like the engineers, the small teams? How do we even get started with a machine learning project, like a small POC, to even prove the added benefit of the solution?
Yeah, sure. I think the origin of inspiration can come from two different ways. So usually, with the marketing around AI right now, people feel a pressure to do something with AI. So this is also kind of okay, but not the most healthiest approach in my eyes, because there is no clear direction of what to do with AI, but only the enthusiasm to do. Sometimes it will turn out to be a good inspiration, that it comes from a top-down approach. But the real best would be that end users, or if you are using a tool that's really taking a lot of time to give out some output, when you give it some input, it's taking a lot of time, and there are a lot of processes linked to this tool, then we know that we can already see that there is a relationship that I can map out. So I'm giving an input, it's going through multiple tools, and then I get an output. Is there a way I can do this process through a machine learning model? So the best way would be to, as engineers, you can definitely look at the tools you're using, the number of steps, or the way data flows. I'm pretty sure if end users or if engineers can map out the way a data flows inside their engineering process or engineering team, they can already see where it takes the most time, or where is the interconnectivity, or the dependability on other factors is too high, and we can start from those points. Okay, these are the points where this point is connected to a lot of different sources, and this is our bottleneck. So we can start from there, see if something is possible, and then try to form a very good use case. So
Uh-huh.
this is for the engineering teams, but also, like I mentioned, if it's a big organization, there is also cost purchasing departments that they can help the engineering teams, and engineering teams can help them vice versa. So this is another possible way.
Yeah, do you feel that there's maybe not enough awareness in the industry of what is actually possible? Because there's like kind of different like I don't know, group of peoples. Some of them think it's kind of the magic pill that solves every piece of their problem. But then there's the other ones that are like super skeptical. And I think the truth is somewhere in the middle, right? It can solve a lot of things, but not everything. So can you talk about some of the use cases that you've encountered or maybe have worked on at Scenera?
Yeah, sure. Like you mentioned, there is this huge expectation mismatch between what is the most effective, what seems futuristic. And I'm a big advocate, like you mentioned, for meeting in the middle. Like, not everyone needs to wrap around a LLM to automate the simplest tasks, and not everything can be automated with a simple linear regression model.
Yeah.
So the use cases that we see in Synera are quite varied, and the most predominant or the most efficient models are that of reduced order models or surrogate models. So this is basically on simulation data. So if you have a lot of simulation CAE data, you can use reduced order model tools like SimCenter ROM Builder, or even Altair's ROM tools, or even new technologies like Navasto. You can integrate them into your workflows on simulation data, and this can already speed up your initial design or development cycle, that you can predict. You can input some parameters, you can already see what the key performance indicators are going to be. So this is the most predominant, and I would say the more engineering use case. And also there is always, so let's say you decide to go to use an external tool, and then there is always this big workload of data preparation. And Scenera is extremely helpful here. So you can prepare for your whole design space, the data set that you would need, including various boundary conditions. And we see some users or some customers really relying fully on Scenera to leverage Scenera's data processing capabilities. But also there are some use cases which are not fully CAE or CAD related, but also even related to geometries, just classifying. Imagine you're a company with hundreds of parts, and for costing of this, you would need to figure out what kind of part is this. So you can use a simple classifier model to classify what kind of a part this is, and then you can trigger that costing logic. So each part would have separate logics for maybe engineering or costing, and usually the step is, if you get in a quote or if you get in a part from someone, you can just put it in, and the workflow will automatically identify what kind of part it is, and then you can select which logics to go ahead. So these are some of the most common and successful use cases that we see in Scenera.
Really cool. I was wondering, before we maybe delve deeper into some of the use cases, regarding the upskilling aspect as engineers, it feels like maybe there's also one misconception out there with it, which is like the high barrier of entry, right? I mean, like there's tons of frameworks out there. It somehow feels almost overwhelming, like where to get started. Would you even say it's a quote unquote smart idea to just jump straight into Scenario and build your POC there, which I think it might be depending on the use case, or should you like, I don't know, start building a neural network in C++? Like, where would you start as an engineer?
Yeah, sure. I can talk from my own experience. So when I really started learning machine learning or AI, it was in 2019 or something. That's when these BERT models came into news, and everyone was really catching up on this AI thing.
Yeah.
And that time, I didn't know something like low code or Synera. So therefore, I took the classic approach. I had to learn Python. I had to learn all the libraries. I still use sometimes Anaconda and things there. So that is the classic way, and it's nice to really go line by line code, see what's in the documentation, and things like that. So, and this is both a boon and a bane. So this is the barrier. I don't think the mathematics of machine learning is the barrier. It's actually simple. So for linear regression, we have points. You just need to fit a line. This is understanding is not the barrier, but the tools to enable access to machine learning is sometimes extremely new for engineers. So if I have to learn a programming language to access this, that is a big barrier for me. And that is where Scenera can help, because Scenera is actually a visual programming language. So it's still a programming language, but we make use of these visual nodes that you can drop onto the canvas. It's just actually coding, but it's easy to really see how the code looks, how the data flows, and really use the custom built nodes to do this. So yeah, I would only propose or encourage always new users starting with Synera that please learn the mathematics behind your ML models. So we really still need to know what's happening behind. But I personally believe the way to access these models will kind of be very easy going into the future, not just through low code, but just imagine you can talk to ChatGPT and it's still going to build a model for you. It already can, but we need to know what are the parameters I need to change, or why am I getting this loss and not some other loss. And I think this understanding and what to tweak there, that knowledge, having that knowledge is super valuable, and the only knowledge is needed. But I think there are many ways to cut this barrier of programming, which I see is the big barrier to accessing machine learning models.
Yeah, I think one of the things I think even Jensen from NVIDIA even said it, like coding is not going to be like one of the major skills in the future, because well, you could ask ChatGPT to code something up for you, right? But I think one thing that always will stay a constant is like the engineering knowledge and intuition behind of
Exactly.
what you actually see on the screen. So I think the cool approach here with low code is you see something on the screen and can immediately assess as an engineer, does it even make sense from a physical point of view? And then you can on top build ML models. And like I think the statistical knowledge about statistical models is a bit like it's not well taught in uni, I would say.
Yeah.
So I think engineers listening to this, I think
Yeah.
in terms of statistical knowledge, they maybe need to upskill themselves, take a couple of courses, and there's a lot of good books, by the way, out there.
Yeah, I agree. Yeah.
Cool. Any other maybe things in terms of like ML advancements? How do you keep yourself up to date with the latest stuff that's going on in AI? There's too much going on, I know, but like, how do you do it?
Yeah, sure. Yeah, I think LinkedIn is a big boost for me, or a daily source of feed for me. So I follow a lot of people from many organizations that are more into this AI and ML to see what kind of their thoughts and their opinion. But this is just general awareness. And what I am also looking at is always I have some really good, credible newsletters that I have always subscribed to. So they send in me some really valuable insights. So one thing that I can just recommend is Alpha Signal,
Yeah.
and they definitely give the latest insights into what's happening every week. And also something I like is Code with Papers. So to stay on the really like research front. I don't know if it's papers with code or code with papers, but yeah. So it's basically they explain the paper along, and you can go inside and see the code of that paper in GitHub. What did they actually do? And this still balances that theoretical knowledge and kind of understanding how they actually implemented it. So this is on the theory side. But for example, I'm lucky enough to be really able on work on practical use cases. Like really, as part of my role as solution engineer, I can work with our extremely inspired users and with machine learning. But I think there's so much, plenty of examples available that anyone can do. For example, if you're students or someone starting with, I would say just think in terms of input and output. See if there is some input going somewhere, some output coming somewhere. Can you cut what's happening in the middle? I think this is the framework that I use in my mind. So when I look at something where input goes, output comes out, I see, is this the most efficient way? Or if there is so much of this mapping available or data available, can I already fit a good model there and get something out? So this is the most easiest way to access. Of course, there is also the classic Kaggle, where there are so many examples. So you don't need to even start with engineering data sets. You can go to Kaggle and see some of the amazing data sets there and just start with. So this is in my experience, the best ways.
Yeah, very cool. In terms of like co-pilots and reduced auto modeling, like what are the capabilities, especially inside of the local environment, such as Scenera, but then also how does it assist engineers, even maybe looking into the future? Because I believe, and you probably have the same, and maybe also a different view, is that AI will be more like an assistant, like Jarvis, right? So how do you see that happening?
Yeah, sure. I think that's, I wouldn't even call it a future. It's happening now as we see. In Synera, there is already a lot of add-ins coming from our partners where you can use reduced order models. So for someone hearing this term first time, so reduced order models are also called surrogate models, or you're basically replacing a FEM model or a CFD model that you would classically build into a simple machine learning model. So we look at simulation data, we try to map out, okay, what was my input, what is my output coming here, and we just, instead of doing a real simulation, we instead use this machine learning model. So as you can imagine, this is already very valuable, especially if you're in the development phase of your products. And you can already use these reduced order models to act, act like AI experts, that knows much better about these kind of analysis. So this is already the present. So inside Scenera, you can already import your FMUs or ONNX file from external tools, or even if you want, you can also build it inside Scenera. And a lot of our customers are doing this, and we see amazing results. And of course, the way Scenera helps here is really preparing the data that needs to be learned. So that is a key advantage here. And also, we are as part of Scenera, we actually believe, yeah, Copilot is the way to go. Imagine you can talk to a tool, get some simulation done. That would be awesome. And I think this also goes hand in hand with the LLM developments. So really, having this multimodality options to see what are the kind of inputs that an LLM or AI can handle. And I think we are not yet there with the geometry and simulation data. We are still lacking there. But for example, if you just want to control using voice or text, or even to look at images, I think this is completely possible. We have some prototypes that we show around of what's possible, and it's always our customers are always excited to see this.
Very cool. In terms of reduced order models, people who are not familiar with it, any particular use case you can maybe walk through, like in 1 or 2 minutes? Like, how does it actually work, like from a practical point of view, instead of
Yeah,
scenario?
sure. Yeah, sure. So imagine you're a development engineer in your initial development stages of a product, and this is a product that is very well known to your organization. You have maybe many variants of this, many design revisions of the same variant, and you performed FE analysis on all of these variants. So there is just a lot of simulation data available. And one simulation, for example, takes hours to do. So this data you collected through running or maybe thousands of FE simulations over the last 5-10 years, maybe, or even shorter than that. And then you have all the simulation data. The idea is to use the simulation data to build an ML model that can do that in less than a second. So what this reduced order model does is it really sees, okay, if this was the input and the simulation results showed me this, then what is the relationship between these? And imagine you train this for thousands of samples, thousands of design variations, thousands of output simulation results, and we try to see, okay, how has this input change affected my change in simulation result? So we are seeing, if I tweak the input here, what is my output here? And the need for this is in the development phase. This usually takes a couple of hours or even days. And if you can bring it to less than a second, imagine the speed at which you can develop products. And of course, a full fidelity simulation is later needed when you have identified the optimal parameters and things like that. But to get to that optimal design configuration, this surrogate model will accelerate your engineering speed. So you don't have to again wait for hours or days to get this KPI that is this design safe or not? What's the safety factor? We really don't need to wait days any longer. It's just in even milliseconds we get it. Is this design safe? What will be the maximum stress? What could be the mass of this part at the end of the all the process? Even what is the displacement if you're developing some kind of dynamic parts? So yeah, if you have some input like design parameters and output like simulation result like maximum stress responses, displacement responses, mass or stiffnesses, we can kind of predict this for every design already.
Really cool. Yeah, we should also mention that we have a kind of a deep dive session with you, Ram, in a couple of weeks. So we would actually show this in action, like how this works using Scenera. So it's going to be really, really cool. How do you personally see the future, Ram, of AI in engineering, like with low code or without low code?
Yeah, sure. The most beautiful quote that always stuck to my heart about AI was, I don't want AI to write novels and make movies. I want AI to clean my dishes and fold my clothes so that I can go and write novels and make movies. And I think this is the same for engineering if you just extrapolate it. We engineers still want to be able to have that feeling or experience of creating, but not really anymore the feeling of clicking 1,000 buttons, doing manual repetitive tasks to get this feeling. The feeling to get this creative, how do you call it? This creative feeling is going to be short. So in an engineering team, I think not even decade, but I think in 1 or 2 years, there will be a lot of advancements, especially LLMs, the way we access this software. So it's still going to be FEM, it's still going to be CFD, surrogates, stuff like that. But the way we interact with these tools and at the speed with which we get the results is going to dramatically change. But I think my understanding is, still engineers want to be on the driver's seat. They want to be able to, or also me as an engineer, I want to be still able to look at the part and see how does this look, and that feeling I think is hard to replace. So I think we will see a lot of advancements in the way we interact with these tools, the way we interact with the software, but I don't think there will come an AI that can replace CFD simulation or FEM simulations accuracy for now.
Yeah, for now at least, correct. Do you have maybe as a closing remark some of maybe the biggest pain point or like fear of end users of AI, maybe also using Scenera, maybe they think they're going to be replaced, and maybe 1 or 2 points of fears or emotional fears of decision makers, what they think AI might do or even disrupt their existing workflows. Do you have anything in mind?
Yeah, sure. Personally, I have never experienced someone saying, I'm afraid AI will take my job away. As an engineer, especially if imagine you're a stress engineer with 20, 25 years of experience building aircrafts, it's not possible that one AI will come in and completely replace. So there is always the need of human experts. So that is never going to be replaced. So until and unless we achieve some hyper intelligent artificial general intelligence, I don't think we will be able to create models with specific domain knowledge. For example, imagine what automotive veteran who developed maybe 10 to 15 car models, they know the whole process, not just simulation. They know project management, they know how to communicate, they know how to write these certification documents. So there is a lot of abilities that are linked to one engineer, and I don't think there will come one AI that can replace all, but there is AIs that are specifically made to replace each of these tasks. So I think there were also, last week I saw a startup that's just targeting on writing legal documents, and they have it as a responsive AI or a regulated AI that writes legal documents. So that is getting replaced. So I think the fear comes from not understanding what AI is or what it can replace actually. And therefore, I would only encourage for everyone who thinks that they will get replaced to actually see what AI is and do a reverse and find out use cases to use AI. So that would be the best way to see if you feel you're doing manual repetitive work. Then the best way to go ahead would be to look at AI models and see if you can yourself build an AI model to manually to eliminate this repetitive task. I think that is the way I see to mitigate this fear.
Mm-hmm.
And sorry, I didn't get the second part of the question, Yusuf.
The second part was more for like decision makers. Like, what do you think their fear is? Like, because we always talk about like, okay, it's like the classical, okay, time to market, reduce time, reduce costs. But I think decision makers probably ask themselves also, what's in for me? Like, if I implement AI, what's in for me, not only for my organization, because they also want to accelerate their career. So do you think there's also a fear for the decision makers, like C-level, CTO, CIO, these kind of people?
Yeah, to be honest, I haven't really worked closely with such personas, like such head of, let's say, real C-level executives. But I've always felt that C-level executives who get the bigger picture that this needs to happen sooner than later usually drive the organizations in a better way. So if someone is leading a digitalization or innovation department and they know to just take the efforts now, right now, even if they haven't taken something now, they have a sense of their mind starts to, or their thought process then gets more mature, and they see, okay, if I do this now, this is going to impact the organization in a such way. And I think the efficiency of such teams or the team that is being led by them is also equally motivated. So when the decision maker has a very good picture of what the small effort today will lead the organization to in terms of digitalization or AI, it turns out to be efficient. And I think for decision makers, there's also another layer of regulations, especially I think with the new EU Act. If you're building critical products, we need to be able to disclose all AI models we used, where did we use them, what was the accuracy. I'm not fully aware of the AI Act, the details, but this is the Act. So, for example, if and a car is a critical infrastructure. So if a car manufacturer is using AI in this multiple process of their whole development, they need to also now be aware of this. So I think that is on the decision makers. So that kind of approval process is on the decision makers. I'm not fully aware of what's happening behind the scenes, but I think for the end users, it's always fun to work with AI. And for decision makers, they just have to make sure everything is compliant, safe, and responsible when using AI. But organizations that every organization would need to do it, at least in Europe. And I think that will say who gets that certification done first. So that's my personal opinion.
Yeah, sounds pretty good. Cool. Ron, thank you so much. Half an hour, we talked about the future of AI and engineering. I would be really keen, or would like to hear what people think about this podcast, maybe in the comments. And then, as I said, we're going to have a deep dive hands-on session with you in a couple of weeks. Yeah, sure. People can experience live what is actually possible with low code and ML models. Yeah, sure. Thank you so much, Ram, and speak to you soon.
Yeah, sure. Any feedback for me from this session? Anything you see could have been better, or?
I mean, we let the audience decide.
Okay. Yeah, sure. Yeah. Okay.
Yeah, definitely. So ask your open questions in the comments, and then we can answer them maybe on YouTube, on LinkedIn, and so on and so forth.
Yeah, sure, Yusuf.
And sounds good. Cool. Thank you so much for doing this.
Thanks a lot. Yeah, thanks so much, Yusuf. Thanks to you.